Welcome to Two Projects. In this video, we are going to explain the project Opinion Mining from Online Travel Reviews and Exploratory Investigation on Pakistan Major Online Travel Services using Natural Language Processing. Introduction. The project focuses on leveraging the vast amount of user generated content available on the internet, specifically online travel reviews, to extract valuable insights through opinion mining. In an era dominated by information exchange, travelers contribute to a wealth of online reviews, sharing their experiences, recommendations, and feedback. The goal of the project is to employ advanced techniques in sentiment analysis to understand and categorize these opinions, providing a comprehensive view of travelers' sentiments towards destinations, services, and products. The travel and hospitality industry faces challenges in managing the overwhelming volume of online reviews. The project addresses the issue of information overload by developing efficient methods to extract relevant insights. With a focus on thematic words and sentiment analysis, the project aims to provide a solution to the ambiguity faced by travelers when navigating through extensive online content. This project is crucial in enhancing the quality of information available to travelers, thereby aiding them in making well informed decisions. And the project holds significance for various stakeholders, including travelers, travel planners, and businesses in the tourism industry. Travelers benefit from more reliable and organized information, reducing uncertainty and aiding decision making. Travel planners can use the insights to tailor services and offerings based on customer preferences. Additionally, businesses gain valuable feedback to enhance their competitiveness, reputation, and profitability. Objective of the project. So, as I mentioned earlier, the primary objective is to extract valuable insights from online travel reviews on platforms like Uber and Kareem in Pakistan. This involves understanding and categorizing sentiments, recommendations, and feedback shared by travelers. And the aim is to utilize Python for meticulous data pre processing, encompassing cleansing and tokenization. The focus is on enhancing efficiency and accuracy in preparing the data for analysis, ensuring a robust foundation for subsequent tasks. The goal is to employ latent dirichlet allocation, that is LDA, as a technique to extract thematic words from online travel reviews. This step aims to identify and categorize common topics within the reviews, providing a structured representation of the content. And the objective also includes implementing advanced models, including convolutional neural networks, recurrent neural networks, multilayer perceptrons, and LDA. And the goal is to enhance analytical capabilities and explore diverse modeling approaches for extracting richer insights from the vast pool of online travel reviews. Requirements needed to execute this project are software requirements. Software needed is Anaconda, primary language used is Python, front-end framework used is Flask, back-end framework used is Jupyter Notebook, database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working models of law of work. So the first step is important required packages. So in this initial step, essential Python libraries such as NumPy, Pandas, Matplotlib, TensorFlow, Keras, sklearn, and NLTK are imported. These packages provide the necessary tools for data analysis, data pre-processing, visualization, deep learning, and natural language processing tasks. The second step is exploring the dataset. So here, the Uber and Karim datasets are explored to understand the structure and content. This involves examining the data's features, distribution, and any initial patterns. This exploration is crucial for formulating an effective strategy for subsequent analysis. The third step is visualization. In this step, word clouds are employed for visualizing word frequency, offering an intuitive representation of commonly used terms. Additionally, sentiment counts are calculated to gain insights into the overall sentiment distribution in the datasets. The next step is data processing. Here, several pre processing steps are executed to clean and prepare the data for analysis. This includes removing unwanted characters, eliminating punctuations, stopping words, and normalizing the data. Label encoding is applied for categorical variables, and tokenization is performed using count vectorizer and Keras tokenizer. The next step is feature selection. In this step, relevant features are selected based on their significance for subsequent analysis. This step is crucial for optimizing model performance and reducing dimensionality. The next step is train and test split. In this step, the dataset is split into training and testing sets to facilitate model training and evaluation. This ensures that the models are tested on independent data to assess their generalization performance. The next step is training and building the model. Here, various machine learning models, including CNN, RNN, MLP, and LDA, are trained and built for both Uber and Karim datasets. These models enable the extraction of insights and patterns from the data. And in the next step, as an extension to the project, to enhance prediction accuracy, a LSTM and a hybrid model is implemented by combining predictions from multiple individual models. This approach leverages the strengths of each model for a more robust outcome. And as an extension again, a user-friendly frontend is developed using the Flask framework. And SQLite is integrated to manage user sign-up and sign-in functionalities. So after signing in, users input data through this interface, and the input data provided by the users undergoes pre-processing steps similar to those applied to the training data. This ensures consistency in data preparation. And trained models are employed to make predictions based on user input. Latent dirichlet allocation, that is LDA, is applied for topic modeling, revealing underlying topics within the textual data. This aids in understanding the main themes present in the content. And the final model predictions as well as the results of topic modeling are displayed on the front end. So users can easily interpret the findings and gain valuable insights from the analysis. Now we'll understand about the algorithms used. So the first algorithm built is convolutional neural networks, that is CNNs. So CNNs are deep learning models designed for feature extraction in grid-like data such as images, or in this case sequential data like text. Utilizing 1D convolutions, CNNs can identify local patterns and hierarchies within sequences of words, making them well suited for capturing relevant features in textual data. In this project, CNNs enhance sentiment analysis by effectively recognizing patterns within online travel reviews. The next algorithm built is recurrent neural networks, that is RNNs. So, RNNs are specialized for processing sequential data by maintaining hidden states that capture dependencies between sequential elements. In the context of sentiment analysis, RNNs excel at understanding the sequential nature of language, capturing contextual information and dependencies within text. By retaining context over time, RNNs contribute to a more nuanced analysis of sentiments expressed in online travel reviews. The next one is multi-layer perceptrons, that is MLPs. So MLPs represent traditional neural networks with multiple layers, allowing for the learning of complex relationships between inputs and outputs. In sentiment analysis, MLPs are versatile and effective in capturing non-linear patterns within textual data. Their ability to model intricate relationships makes them valuable for extracting nuanced insights from the diverse content of online travel reviews. And the last algorithm built is linear discriminant analysis, that is LDA. So, LDA is a statistical method employed for dimensionality reduction, particularly useful in classification tasks. In the project, LDA is utilized to reduce the dimensionality of features while preserving the separability between different sentiments or topics. By focusing on the most discriminative features, LDA enhances the project's ability to classify sentiments in online travel reviews. Now we'll see the comparison graphs of the algorithms built using Uber dataset. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. Accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. These are the comparison graphs of the algorithms built using Karim dataset. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is data folder in which I have Karim and Uber datasets with class labels on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. These are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And these are Jupyter source files which contain a combination of code, graphs, and outputs all in one place. So Jupyter source file allows users to write and execute code in individual cells, making it a popular choice for data science. This is topic modeling Python main code file and this is the signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file Explorer. I'm copying it. Open Anaconda prompt. Now use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, local host, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password and click on login button. So it has redirected us to the classification page. So here we can see a prediction link, click on it. So we can execute this project using two datasets, Uber and Karim. So first we'll execute it using Uber, click on it. So here we can see a enter your message box where we have to enter a message and the application will classify its sentiment. So I have entered this message. Now click on predict button. So this is the entered message and here we can see the classification. So the application has classified this message as a negative sentiment. And here we can see the topic for the paragraph is most dependent upon. So dependent upon these words, the application has classified this message as a negative sentiment. We'll try again. Click on prediction link, click on Uber link. We'll try giving another message. So I have entered the message. Now click on predict button. This is the entered message, and here we can see the classification, that is positive sentiment. So the application has classified this message as a positive sentiment, and here we can see the words dependent upon which this message has been classified as positive sentiment. Now click on prediction link. We'll execute the project using Karim dataset. Click on it. So we have to enter the message here. I have entered the message. Now click on predict button. This is the entered message, and here we can see the classification, that is positive. So this message has been classified as positive, and here we can see the words dependent upon which the message has been classified as positive. We'll try again. Click on prediction link. Click on Karim link. I have entered the message. Click on predict button. This is the entered message, and here we can see the label, that is neutral. So this message has been classified as neutral sentiment, and here we can see the words dependent upon which this message has been classified as neutral. Click on prediction link, click on Karim link. We'll try with another message. I have entered this message. Now click on predict button. This is the given message, and here we can see the classification, that is negative. So similarly, we can give any message and can get the classifications of the sentiments. Now click on sign out. So the conclusion here is the project successfully implemented and explored various advanced algorithms including CNN, RNN, MLP and LDA to conduct a comprehensive sentiment analysis of online travel reviews. This multi-algorithmic approach allowed for a thorough understanding of sentiments expressed by travelers. The integration of extensions, LSTM, and a hybrid model combining predictions from individual algorithms contributed to enhanced prediction accuracy. This approach synergized the strengths of diverse algorithms, providing a more robust sentiment analysis outcome for online travel reviews. The project not only classified sentiments but also provided valuable insights into the nuanced opinions expressed by travelers. By employing sophisticated models, the analysis went beyond polarity classification, offering a deeper understanding of the diverse sentiments present in the dataset. And the development of a user friendly front end using Flask, coupled with user authentication through SQLite, ensured a seamless and secure user experience. This allowed users to interact with the sentiment analysis system, providing input and receiving meaningful insights in a structured manner. So, this project aimed to improve decision making in the travel industry by understanding sentiments in online reviews. It provides helpful insights for travelers and helps businesses in responding effectively to customer opinions. Overall, it empowers both travelers and businesses to make better informed decisions.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.